So let's look at factoring over the complex numbers and how that process works. So we're going to take a quadratic equation, and it's a quadratic equation when it has an x squared term. So let's look at this one. 2x squared plus 6 is equal to 0. This is a quadratic equation, even though it doesn't have an x term in the middle. And that's part of what makes it a complex number. We're going to have that I term in the middle somewhere. We would normally look at this and say, oh, well, we can't factor that. That's just not doable. So this is how we would do what's not doable, right? First of all, we have a lead coefficient. We need to get rid of the lead coefficient. So we're going to divide everything by 2 and factor this out. So we have 2x squared plus 3 is equal to 0. So we know 2 is not equal to 0. So the x squared plus 3 has to be equal to 0, right? So that's what we would do. We'll set this equal to 0 first. So x squared plus 3 is equal to 0. Now we're going to subtract the 3 from both sides. Actually, I don't need to write that step. You guys know that by now. I can just write x squared is equal to negative 3 because we know we subtracted 3 from both sides. But now we have to unsquare x. So if we unsquare x, we get x is equal to plus or minus the square root of negative 3. Well, we know we can't have a negative in the square root. So it's going to be x is equal to plus or minus square root of 3i. So there's our complex number. There's where it comes from. But now we want to be able to factor this. We can't factor it like this because it's an expression. We have to put it back into that expression form now that it has been unsquared. So that's what we're going to do. We are going to split this apart into both the positive and the negative. So we would have x is equal to the positive form of 3i, and then x is equal to the negative form of square root of 3i. So now we're going to subtract and add to both sides. So we end up with x minus square root of 3i is equal to 0, and x plus square root of 3i is equal to 0. So now we have this factored. So all we have to do now is put everything back into the factor, right? So we would say 2 times x minus square root of 3i times x plus the square root of 3i is equal to 0. Now we have broken what we thought we could not factor before into complex numbers that are then it's factorable. We were able to do that. And so that's how we would factor over the complex number and break it down. And if we were to take this and multiply, we would eventually get right back to 2x squared plus 6. So let's do a practice problem or two. Let me see how many we have. Looks like we just have 2 practice problems. It doesn't look super difficult. I think we can do these just fine. So let's do 46.2 and knock that one out. So we need to factor 2x squared plus 4x plus 8 over the set of complex numbers. So the first thing that we're going to do is we are going to, and let's just go ahead and set this equal to 0 just to give ourselves that equation. We're going to take out our lead coefficient as a factor. So we're going to divide everything by 2, so it looks like this. 2x squared plus 2x plus 4 is equal to 0. All right, and we couldn't factor that normally because negative 2 times negative 2 would give us negative 4. Positive 2 times positive 2 would give us a positive 4. So we wouldn't be able to normally factor that. So we're going to give it over to our complex numbers. So we are going to see how we can do that. because we have this x in here, it's actually going to be easier for us to use the quadratic formula, I believe. I think that's what we'll do. Because we have 3 terms, the quadratic formula is going to be the easiest way around this one right here. If we only had the 2 terms, then we could do it the other way, the way that we showed in the original 2x plus 6. But because we have this extra term here in the middle, it's easier to just use the quadratic formula than to try to factor, because that gives us the factors that we need. So let's just do that. So because we've taken our lead coefficient out, our A is equal to 1, our B is equal to 2, and our C is equal to 4. So remember the quadratic equation, the quadratic formula, negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A, which would just be 2. So x is equal to negative 2 plus or minus the square root of 4 minus 16. So that would be negative 12 divided by 2. So I can get rid of this. I don't know why I have this really long tail right there. All right, so now we can factor this out. Negative 12, we're going to get rid of this negative and make it an I, right? So we're going to get rid of the negative there by pulling that I out. And now we can factor this 12. We know that that would be the square root of 4 times the square root of 3. So we can bring a 2 out of that. So then this would become 2 times the square root of 3i. And because we have a 2 here and a 2 here and a 2 here, we can reduce all of this, and x would be equal to negative 1 plus or minus the square root of 3i. This is now where we were before. We have the value of x with both sides, with the positive and the negative terms. So that's what we're going to do. We're going to come over here, and we're going to write this out. X is equal to negative 1 plus square root of 3i, and x is equal to negative 1 minus square root of 3i. And now we're going to just put that in parentheses, treat it as one term, and we're going to subtract it from both sides. So x minus negative 1 plus the square root of 3i is equal to 0. And x minus negative 1 minus the square root of 3i is equal to 0. We apply this negative 1 to everything, and x plus 1 minus the square root of 3i is one factor, and x plus 1 plus square root of 3i is equal to 0 is the other factor. So now we can go back and take that lead coefficient and say 2 times x plus 1 minus the square root of 3i times x plus 1 plus the square root of 3i is equal to 0. This is the fully factored form of this original quadratic equation. All right, if anybody is lost, raise your hand. I won't see you because I'm on the other side of the video screen, but you can raise your hand anyway. Sorry, that was just a really bad joke. So just message me if you're struggling with this. We've got one more practice problem. So remember, it's not about how we did the first one. It's about applying which method you can use. Like if this is factorable, then factor it, and that's okay. But if it's not factorable, then use the quadratic formula, and then we can turn that into the factors there. We can take all of that we've been doing with the quadratic formula and put it back in as a factor. That's really what we're learning how to do, is to take all of this stuff when we get this weird number at the end. What do we do with it? How does it work? How does it apply? This is how it applies. So let's do 46.3. And we'll go through it a little bit more slowly just to give everybody a chance to kind of grasp all the little moving parts. So we're going to factor. Here we have no lead coefficient, so that makes it a little bit easier. We have x squared plus 2x minus 5. Yeah, so we're going to subtract, or I'm sorry, we're going to set that equal to 0. And we are going to look at this for just a second and think to ourselves, what is my best method here? How am I going to get this? Well, the only factors of 5 are 5 and 1. That's not going to give us 2x in any way whatsoever. So we're going to have to use the quadratic formula again. So let's just do that. So x is equal to negative b, which is negative 2, plus or minus the square root of 2 squared minus 4 times 1 times negative 5 over 2 times 1, so it'll be 2. So x is equal to negative 2 plus or minus, and that is going to be a square root of 4 plus 20, so 24 over 2. We know that 24, our factors of 24 are going to be 6 times 4. That's the only square we can pull out. So we have x is equal to negative 2 plus or minus 2 times the square root of 6 over 2. So this reduces, and x is equal to negative 1 plus or minus the square root of 6. That's it. That's what we have right here. So now we can factor this out. We're going to do our plus or minus just like we did before. I'm going to erase this. We don't really need that anymore. So we have x is equal to negative 1 plus the square root of 6. X is equal to negative 1 minus the square root of 6. Treat that as a whole term and subtract it from both sides. X minus negative 1 plus the square root of 6 is equal to 0. And x minus square root of 1 minus square root of 6, or negative 1 minus square root of 6 is equal to 0. So apply the negative 1 to both of those, and x plus 1 minus square root of 6 is equal to 0. That's a factor. X plus 1 plus square root of 6 is equal to 0. That's a factor. So those are our two factors for this quadratic equation. X plus 1 minus square root of 6 times x plus 1 plus square root of 6 is equal to 0. And that's it. That's our final answer. So it's not super hard. We've been doing this for a long time. Now we just know how to use it and what to do with it and how to put it back in when we need to. All right, so that is all we have for lesson 46. I'll see you in lesson 47. And go ahead and do those practice problems while it's still fresh in your mind. See you soon.